Example for the div instruction. We assume the initial values inside ECX, EDX, and EAX to be 2, 0, and 8 in base 16. And we try to understand the effect of these instructions on the values of these registers. The first instruction is div ECX. It is going to divide EDX, EAX by ECX. Actually, it meant dividing 8 by 2, which is actually 4. The next instruction just increased ECX. ECX was previously 2 and now it turned into 3. And in the next instruction, we are going to divide EDX, EAX, this time by 3. Because ECX is 3 at this point. And we get a quotient of 1 and the remainder of 1. The quotient is actually 4 divided by 3, which is 1. At least the integral part is 1. And the modulus, 4 modulo 3, is 1. Another example. Let's assume those initial values inside EBX, EDX, and EAX. 3A, 20, and 0. We will try to understand the effect of those instructions on the values of those registers. First one is div EBX. This is going to divide EDX, EAX, which we can see here, by EBX. Note that the number that is going to be divided by EBX is actually this whole number, which is pretty large. It is 2, which is followed by 9 zeros. A pretty large number. It is going to be divided by 3a. Also note that if EBX was smaller, we could experience a quotient overflow here. But EBX is large enough so that the result could fit inside exactly one D word, as we are going to see next. D word actually means 32 bits. I'm going to use this word from time to time. D word is actually usually referred to as the size of EAX, EDX, and so on. We are going to discuss it a bit further when we go into the usage of assemblers and some kind of real assemblers like flat assembler, fasten. The result of the first instruction, div EBX, we get the quotient in EAX, which is this strange number, and we also get the remainder inside EDX. The remainder makes sense because it is smaller than the divisor, 3a. It always must be smaller than the divisor. The next instruction is div bx. It is going to divide ax dx by bx. Actually, the number that is going to be divided is this one. It begins with those 16 bits, 0, 0, 3, 0, and it continues here, CB08. This is going to be divided by 3a, by this part, the lower part of EBX. And we get this result. We get the quotient inside AX, and we get the remainder inside BX. Now this is followed by a simple move instruction that is just going to copy this value inside BL, and we get FE inside BL. Now we are going to divide AX, which is this value, D756. This is going to be divided by BL. BL is FE. And we get that the quotient is D9, and the remainder is 0e. Both of these are stored inside AX. 0e is stored inside AH, and D9 is stored inside AL. Summary of the instructions we have seen this lesson, and we have seen many instructions this lesson. Inc and dec allow us to increase and decrease by 1 correspondingly. Okay, inc is increasing and dec allows to decrease. The mul instruction allows to multiply numbers. We have seen that it has 3 forms. It even has more forms than that. It has 4 forms if we are speaking about the 64-bit version too. But in the 32 version it has 3 forms. We can multiply EAX or AX or AL, and the results are inside those correspondingly in EDX and EAX, DX AX, AH AL, and so on. This is where the result is usually stored. The div instruction allows to divide numbers. And just like the mul instruction, it has this kind of 3 modes. The shortest one allows to divide AX, which is also the oldest one historically. This kind of division was present in the very first processors of the x86 architecture. The very first one. The next one, the 16 bits version, allows to divide DX-AX by some number of size 16 bits. And the last one allows to divide a very large number, a 64-bit number spanned over EDX and EAX, by some number of size 32 bits. Some exercises that you could do now. You are going to see some code reading and some code writing. And this is mostly going to be a bit dry because you are not going to run the code that you write yet. But this is a very good practice and I recommend you to do this. The next lessons that we are going to do are going to be probably a bit more practical. But these are the very first ones and it is very important that you will have a strong basis. It is also very important that you grasp the new instruction that you have just learned. About the exercises, as usual, there are some bonus exercises. Maybe if you are bored with the usual exercises, then you can do the tougher ones. But they are not mandatory. You can just skip them if you want to move on. And you are supposed to be able to understand the next lessons, even if you only do the mandatory exercise. So have fun and see you next time.